Welcome back. In our previous lesson, we have looked at how we can decompose rational expressions into partial fractions, and we've considered a type whose denominators have irreducible quadratic expressions. My name is Nanaya Wedu, and you can call me Senana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In this lesson, we want to consider how we can decompose rational expressions, but I want to look at improper rational expression types. So what does it mean to say that a rational expression is improper? So for rational expressions, we say that when the numerators have degrees greater or equal to the degrees of the denominator, then they are improper. So for instance, if you have the numerator being x squared plus 2x plus 1, and then we have the denominator to be also x squared minus 6x plus 1. Then the highest power of the denominator is 2, and that of the numerator is also 2. So we say that this type of expression is improper, right? It's improper. Or we can also have an expression where we have x squared plus 2x plus 1 all over x cubed minus x squared plus 6x minus 4. So we see that the denominator have a higher power, which is 3, or a degree, which is 3, than the numerator. And in this case, to be able to express it as a partial fraction, all we must do is to use long division first to be able to decompose it so that we can have a constant with an expression that is proper, so that we can express that in partial fraction form. So let's consider this example. So the example says that express x cubed plus x squared plus 2 all over x minus 1, x squared plus 1 in partial fraction or as partial fraction. So let's consider how we can solve this question. So the question given to us is that we have to express x cubed. So we have x cubed plus x squared plus 2 all over x minus 1, and then x squared plus 1. So to be able to do that, just by inspection, we can see that when we expand the denominator, we get a power that is of the same power as the numerator. So let's expand the denominator. So we have x cubed plus x squared plus 2 all over x multiplying x squared will give us x cubed, right? X multiplying 1 will give us plus x. Negative 1 multiplying x squared will give us negative x squared. Then negative 1 multiplying 1 will give us minus 1. So we can rewrite this as x cubed plus x squared plus 2 all over. Let's group like terms here, or let's move the powers well. So we have x cubed minus x squared plus x minus 1. So this implies that in long division form, we are going to have the divisor to be x cubed minus x squared plus x minus 1. And then the dividend in this case is going to be x cubed plus x squared plus 2. So applying long division, we see that x cubed will divide x cubed 1. 1 multiplying x cubed will give us x cubed, right? 1 multiplying minus x squared will give us minus x squared. Then 1 multiplying x will as well give us plus x, and then we'll have minus 1. Then we subtract. So x cubed would cancel x cubed, or we'll subtract from x cubed. Then we are going to have x squared minus x squared. So that will give us 2x squared. Negative negative gives us positive. There's no x term here, so the negative will affect the x, and we have minus x. Then we have 2 minus 1 gives us plus 3. So therefore we can express the partial fraction here, or the rational expression, as 1, right, plus the remainder, which is 2x squared minus x plus 3 all over the divisor, which is x cubed minus x squared plus x minus 1. So that implies that we can write this as 1 plus 2x squared minus x plus 3 all over. We expanded x minus 1 and then x squared plus 1 to get this. So we can write it as x minus 1, right? X squared plus 1. So we can consider just the proper rational expression, which is 2x squared minus x plus 3 all over x minus 1, right? X squared plus 1, and that is going to be equal to, right? So we want to express it in a form that we can use partial fraction to decompose. So we have a all over x minus 1, and I believe by now you know why it's a over x minus 1. We see that x minus 1 is a linear factor, so we can take a constant a and divide it by x minus 1. So plus, when we look at x squared plus 1, it is irreducible because when we equate it to 0, we are going to get a complex number for the values of x. So write it as what? Bx plus c all over x squared plus 1. So now since we have this, we can go to the right hand side and then we will have 2x squared minus x, right, minus x plus 3 all over x minus 1, x squared plus 1 is equal to, we can find LCM here, which is x minus 1, x squared plus 1. So when we take the a, right, we see that x minus 1 will go into x minus 1. We're left with x squared plus 1. So x squared plus 1. Then plus bx plus c. Let's put this into brackets. And then we'll have that multiplied by x minus 1. So we have the denominators to be the same. So we equate the numerator, which is 2x squared minus x plus 3 is equal to a multiplying the expression x squared plus 1 plus bx plus c multiplying the expression. So let me write this well. So we have plus bx plus c multiplying the expression x minus 1. Very good. So now that we have this, we can go by taking the factor x minus 1, right? So we can take the factor x minus 1. So when we take the factor x minus 1, we are going to have x minus 1 to be equal to 0, right? So that implies that our x will be equal to 1. So we'll substitute x is equal to 1 in place of x here. So that means that we are going to have 2 multiplying 1 squared minus 1, right, plus 3 to be equal to, and in that case you are going to have a multiplying the expression 1 all squared plus 1, right, plus we have our b multiplying 1, right, plus c, then we have 1 minus 1. So we see that this is 0, so this side goes to 0. Then we are going to have 2 multiplying 1 squared gives us 2 minus 1 plus 3, right? So it's equal to 2a. So 2 minus 1 gives us 1. So 1 plus 3 is equal to 2a. So that implies that we will have 4 to be equal to 2a. Now when we divide both sides by the coefficient of the a, we are going to have our a to be equal to 2, right? So now that we have our a to be equal to 2, we can consider having x to be equal to 0 because there are no factors here again. So we can have our x to be equal to 0. And when we have x equal to 0, we are going to substitute x to be 0 into this side. And it means that you are going to have 2 multiplying 0 all squared minus, right, 0 plus 3 is equal to, right, we will have a, the expression will be 0 all squared plus 1, right, plus b, we are going to have multiplying 0 plus c multiplying 0 minus 1. So in this case, this side, we are going to have 3 here, and that will be equal to, this side is going to be a, right? And then we'll have c multiplying -1, so a minus c, right? So it means that we have a minus c to be equal to 3, right? So now that we have a minus c to be equal to 3, we can let this be equation 1, right? So this can be equation 1. And then we are going to go into our second equation where we are going to have, right? So we are going to have probably another factor x to be equal to -1, because we've used x to be equal to 1. We've gotten a to be equal to 2. And then we've also used x to be equal to 0. And we've gotten probably something more of an equation in terms of a and c. So we can also use x to be equal to -1. And in the case of x is equal to -1, it means they are going to have 2 multiplying -1 all squared, right? Minus -1 plus 3 to be equal to a, we have -1 all squared plus 1, right? Plus we have our b, -1 plus c, and this multiplying, right, the expression -1 minus 1. Right, so with x being -1, we are going to have 2 here plus 1 plus 3 to be equal to 2a, right? In this case, you are going to have minus 2, right? Bracket open, we have minus b plus c, right? So we are going to have 6 to be equal to 2a plus 2b minus 2c. So in this case, you are going to have 2a plus 2b minus 2c to be equal to 6. Let's call this equation 2. So from equation 1, since a, right, so put a, which is equal to 2, into equation 1. So we get that to be equal to 2 minus c is equal to 3. So that implies that we are going to have our c to be equal to 2 minus 3. And our c will be equal to -1, right? So our c is equal to -1. So we are also going to substitute our a and our c into equation 2 so that we can get our b. So we are going to have 2 multiplying 2 plus 2 multiplying our b, which we are looking for, minus 2 multiplying -1, right, is equal to 6. So that implies that we are going to have the expression to be equal to, right? So in this case, you are going to have that expression to be equal to, right? 2 multiplying 2 will give us 4, right? Plus 2b plus 2 to be equal to 6. So it means that our 2b will be equal to 6 minus 2 minus 4. And it means that our 2b will be equal to 0, right? So we have 4 plus 2. Then we move 2, we move 4. So that is it. So we are going to have our b to be equal to 0, right? So now that we have our a, we have our b, and then we have our c, we can express our partial fraction, which is, or our expression, which is x cubed plus x squared plus 2 all over x minus 1, right? And x squared plus 1 to be equal to, first we have 1. Realize that when we did the long division, we got 1 first. So plus our a is 2 all over x minus 1. Now we see that our b is 0. So it means they are going to have minus, right? The c is -1. So minus 1 all over s squared plus 1, right? So it means that our expression here, right, in partial fraction form will be an expression, right, with a whole number 1 plus a, which is 2 all over x minus 1. Since b is 0, it means that b and x will go away. Then we only have the c term, and c is -1, so that brings a negative here. So minus 1 all over s squared plus 1. So even when you have an improper rational expression, you can go through the process of long division to be able to break it down in a proper form so that we can use partial fractions to be able to decompose it. So I'll give you this to be able to try and resolve 2x squared plus 9x minus 32 all over x plus 5 and then x minus 4 in partial fraction form. Make sure you leave your answer in the comment section. So all too soon we have come to the end of our lessons on functions. We've gone through the process by looking at functions as something that we deal with in our everyday life. In fact, as a mathematician or somebody studying mathematics, if you want to function well in life, then you must make use of functions. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. See you in the next lesson.